Okay, so I can write down here. So the first example is here. How to solve this guy. We learned the two ways. One is the substitution. Another way is elimination, right? Now I want you guys to use the elimination method to solve these two equation system. Okay, 1 and 2. Now let me solve it on board. So we have two equations, 1 and 2. If we wanted to use the elimination to solve this equation system, we wanted to eliminate one variable, right? So here in this equation, we can clearly see here's a negative y, here's a positive y. So we can directly use the addition, right, to eliminate this y variable. So basically, so x plus 2x is gonna be a 3x. So I'm gonna skip some steps. Negative y plus y gonna be a 0. 1 plus 3 gonna be 4. So it should be a 1 plus 2, right? 1 plus 2. Should be x plus 2x gonna be 3x. Negative y plus y should be 0. So 1 plus 3 is gonna be a 4, right? And then we can solve it. We're gonna get 4 over 3. 4 over 3. Okay, 4 over 3. Now, after we get 4 over 3, we can plug in back the first equation. We have 4 over 3 minus y equals 1. And we can solve it. We get the solution for the y going to be 1/3. 1/3. Okay, 1/3. That's right. 1/3. So we know the solution set is going to be 4 over 3, 1/3. 1/3. Yeah. So that's the elimination. Now, I want you guys try this one. Solve this equation system for me. I think some of you maybe struggled. Okay, so let me solve these problems on board. Okay, let's take a look. So for this problems, since we have x, here's 2x, right? We can eliminate the x variable. So basically, what are we gonna do? We'll let the first equation times 2, right? The first equation times 2, we're gonna get 2x plus 2y equals 6. 2x plus 2y equals 6. Right? If we let the first equation times 2 for both sides, we get a 2x plus 2y, 2 times 3 is going to be 6, right? 6. We get exactly the same two equations. What does that mean? They have the same solution. That's right. That's right. If you do the elimination, for example, we just let 1 minus 2, we're going to get 0 equals 0, right? So basically, we just one equation. There's no two equations. Although I write down as two equations, but basically we just have one equation. That equation is x plus y equals 3. Right? Equals 3. So how to solve this guy? We're going to use the parametric representation because we have two variables. We're supposed to have two equations, right? Two unknowns, two equations, then we can get a specific solution. If that's no, that means we're going to use parametric representation, right? So parametric representation, we just follow the steps. Follow the steps. We use one variable to express to the other one. Right? Y equals 3 minus x. 3 minus x. Then we let x equals t or s. Then y equals 3 minus t. Okay, so the solution set for this equation system gonna be x equals t, y equals 3 minus t. That's it. That's it. Okay. So that's the parametric representation. T can be any real number. Real number. Okay. Well, that's a very typical example. Now, another example. Solve this one for me. Okay, I'm gonna show you for this example. Did you get the solution? What's the solution for this equation system? Did you get the solution? No, that's wrong. No solution. Good job. No solution. Okay, so let's take a look this problem. X plus y equals 3, x plus y equals 1. So if we use the elimination, that's gonna be x minus x gonna be 0, y minus y gonna be 0, right? 3 minus 1 is 2. 0 equals 2. That's impossible. So that means we have no solution. Okay, we have no solution. Why is that? I'm gonna draw a picture. Okay, so we have two equations. That means we can draw two lines. Okay, two lines. Let's take a look. For the first equation, that is x plus y equals 3. We can let x equals to 0. We're gonna get a y 0. Y 0, we can get x equals 3. So connect to these 2 points. We can get the first line. The first line gonna be x plus y equals 3. For the second line, x plus y equals 1. So it's here. Should be x plus y equals 1. Okay, what you can tell from this picture? These two lines are parallel to each other. That means what? They have no intersection point. If there is a solution, that should be an intersection point. Understood? Clear? So they are parallel to each other. That means we have no solution or no intersection point. Okay, that's it. Okay, now we can do some conclusion. Conclusion. The number of solutions of a system of linear equations. Number of solutions of a system of linear equations. So the first case, the system has exactly one solution, and the system, second case, the system has infinity many solutions. 3, the system has no solution. The first two we called consistent system. Consistent system. And the last one we called inconsistent system. Okay. And basically we'll do some conclusion from our previous examples. The first one is the system has exactly one solution, represents this equation. For this equation system, we have only one solution here, right? And the second one is the system has infinity many solutions. That means the second example. The second example gave us the solution here, x equals t, y equals 3 minus t. And since t can be any real numbers, so that means we have infinity solutions. That's the second example, tells us, right? And for the third case, the system has no solution. That means the third example. Third example gave us no solution. That means these two lines are parallel, right? Are parallel. That's it. Clear? Okay, so today we're gonna move to another way. But the first thing I want you guys use the back substitution to solve the linear system. The first example is here. Let's take a look. Use the back substitution. We mentioned a little bit the elimination. Now we're gonna do some back substitution. The fourth example gonna be here is x minus 2y equals 5. Back substitution, y equals -2. Okay, so if I give you this equation system, and we have y equals -2, that means we can do the back substitution. Okay, back substitution to get the solution x. So we just needed to plug in this y to here. So x minus -2 times -2 equals 5, right? And that gonna give you x plus 4 equals 5. And x equals 1, okay? And we're gonna get the solution, gonna be solution gonna be 1 and 2 solution sets, 1 -2, okay? 1 -2. That's the solution set for this equation system. Now let me give you guys another example. Let you guys try it. Did you already write down all the stuff here? Okay. No. So the first equation x plus minus y plus 3z. Okay, so I want you guys use back substitution to solve this 3 by 3 linear system. And the step is gonna be here. Since we already know z equals 2, you're gonna substitute back this equation, okay? And then you're gonna get the solution y. After you get a z and a y, you can substitute these two to this equation, and you're gonna get the value x. Okay, that's the strategy. That's the way we call it back substitution, right? Did you get the answer? What's your answer?
1, -1, 2.
Okay, very good. How about you? Did you get it? Okay, very good. So let's move on. Here we just need to substitute z equals 2 to this equation, and we're gonna solve the y, right? And the y equals -1. So we got the z and the y. We just needed to substitute then in equation 1, right? Equation 1. Substitute y, substitute z. We have -2 times -1, 3. Oh, yeah, z is 2. And we're gonna get x plus 2 plus 6 equals 9. And the x gonna equals 1. So the solution for this linear equation system gonna be x equals 1. Oh, just write down it this way. 1, -1, the 2, right? X, Y, Z, X, Y, Z. X equals 1, Y equals -1, Z equals 2. That's it. I'm gonna give you guys another one. For example, here. try to solve this one for me. Use the back substitution, follow the steps, okay? What's your answer?
15 and 4.
Good job. Good, everybody should get it, right? Okay, I'm gonna do it very quickly. It's not too hard. So back substitution, plug in the z here, we're gonna get y. And y equals 4, right? And now we plug in these two to the first equation. We're gonna get x minus 3 times 4 plus z, and x gonna get 15, right? 15. And the solution set is gonna be 15, 4, and 1. That's it. That's it. Very quick. Okay, so now I wanted to combine the elimination method and back substitution, because later we're gonna use a matrix form to do some basic operations, and in the matrix we're gonna use the elimination and back substitution. Okay, so let's take a look. The first example. Using the elimination to solve this guy. X minus 2y plus 3z equals 9. Negative 4. 2x minus 5y plus 5z equals 17. Okay, for this guy, the first things, if we want to eliminate the x variables, okay, so suppose we want to eliminate the first variable x, okay, just follow the steps. Eliminate the x for the second and third equations. I want to eliminate this x and this x. Okay, the second and the third equations. Okay, so what are we gonna do? For the second equation, we just let what? Add 1 plus 2, right? 1 plus 2. One plus 2, because here is x, here's negative x, right? Negative x. Clear? X and negative x. So just add it together. X minus x gonna be 0, right? So negative 2y plus 3y gonna be y. 3z here. And 9 plus negative 4 gonna be 5. Understood? Just add it together. X plus negative x gonna be 0. Negative 2y plus 3y is y. 3z here, right? And 9 plus negative 4 gonna be 5. So 1 plus 2 gonna be y plus 3z equals 5. Clear? Very good. For the third equation, we can say here's a 2x. And here is x. What are we gonna do? We're gonna take a look. The third equation, we're gonna do 2x. So we're gonna add 1 times negative 2x or negative 2. Let the first equation times 2, right? Times 2 or times negative 2, whatever. Times negative 2. So then we do the addition. Okay, so what are we gonna do now? In order to make everything very clear, I wanted to do like that. So I want to let the first equation times 2 gonna be 2x, 4y, 6z equals 18, right? Let the 2 times x times the first equation gonna be 2x negative 4x, no, negative 4y plus 6z equals 18. Okay, so the third equation subtract this equation, right? Subtract this equation. So what are we gonna do? 2x subtract 2x gonna be 0. Negative 5x subtract negative 4y gonna be negative 5y plus 4y, negative y. 5z subtract, subtract 6z gonna be a negative z. 17 subtract 18 gonna be a negative 1. You need to understand this step, what I'm doing. I skip a lot of steps. So first of all, I let the first equation times 2. Should be here, right? 2x minus 4y plus 6z equals 18. That's the 2 times 1, right? 2 times 1. So here, what are we gonna do is let the third equation subtract 2 times 1, right? So here, so we do the subtraction. Third equation is here. 2x subtract 2x gonna be 0. Clear? Because basically we want to eliminate the x variable, right? So what are we going to do is 3 minus 2, 1, because here is x times 2. We do the subtraction. We're going to eliminate the x variable. Okay, so here is negative 5y, subtract negative 4y. Subtract negative, positive 4y. So negative 5y plus 4y going to be a negative y. And 5z subtract 6z gonna be a negative z, right? Subtract. So here 17 subtract 18 gonna be a negative 1. Okay. A lot of operation inside. I skip a lot of steps because I assume you are guys the expert of the algebra. You already take a lot of courses before, so I'm afraid to skip these steps. Okay. So we get these two equation system. New two equation system. Basically, we just copy it. We get these three equations, and these two are the new equations, right? We just do the elimination. We eliminate the x variables. Okay. Now let's check these two equations. We still have y variables. Y variables. The first step, we eliminate the x variable for these two equations. Now I want to eliminate the y variable for the third equation. Okay, the third equation. How to eliminate? Aha. We just let what? Any idea how to eliminate this y? We just let 5 plus 6. Do you see it? Here's a y, here's a negative y. Just do the addition. Y plus negative y equals 0, right? So we can 3z plus negative z gonna be a 2z. And the 5 plus negative 1 gonna be a 4. Okay, and then you can solve the z equals 2, right? Equals 2. Z equals 2. And very good. Now we can get the equation system. Aha! How to solve this linear equation system? How to solve it? This linear equation system. Back substitution, right? Do it by yourself. Just do it by yourself. We already get this very simplified linear equation system. And you realize that we can use back substitution, right? Just try it. Okay, I'm going to show you the answer. So here we substitute this z to equation 8. We're gonna y equals -1, right? And we substitute back to the first equation. We have -2, -1 plus 3 times 2 equals 9, right? And we're gonna get x equals 1, okay? So the solution set gonna be 1, -1, 2. Okay, that's it. So if you solve the, for example, 3x3 equation system, you can use the elimination method. And when you use the elimination, you always try to boil it down to the equation system like that. Okay, like that. Then you can use the back substitution to solve it. Okay, to solve it. So that's the combination of the elimination and the back substitution. Now I'm gonna give you guys an example. Let you guys practice. Okay. X Okay, solve this guy for me. Okay. So the first step, we want to eliminate these two, this variable x, right? After you eliminate this x, we're gonna eliminate the y for the third equation. Okay. So follow the steps from the first example. Okay. The first example, step by step. Okay. Eliminate x firstly, then eliminate y. Okay, eliminate y variable. You get it? You have some trouble? Did you get the answer? One more minute, okay? Follow the way I show you in the first example. The first step, eliminate the x in equation 2 and 3. And then eliminate the y variable in equation 3. Then you can use back substitution, right? Back substitution. Okay, due to the time limit, I'm gonna solve it on board. Okay. 1, 2, 3. We have 3 equations, right? 3 equations. So, how to eliminate the x in equation 2? We just let the second equation subtract the first equation. Okay. Second equation subtract the first equation. We're gonna have x subtract x gonna be a 0. Y subtract negative 3y gonna be a plus 3y, 4y. Negative z subtract z gonna be a negative 2z. 18 subtract 4 gonna be a 14. Is that right? Okay, so we're gonna have what? We're gonna have so x 4y negative z 14. So 2y minus z equals divided by 2 for both sides. 7, right? 7. Okay, now let's take a look. The third one, third equation, we have 2x. That means 3 minus 2, 1. 2 times 1. So we have 2x times 2x. 2 should be 2x, 6x, 2z equals 8. Right? Equals 8. 2x, 6x, 2z equals 8. So 3 minus 2 times 1 gonna be 2x, 2x cancel. Y, so that'll be a 7y. Z, subtract 2z, negative z. 35, subtract 20. Oh, this one is a little bit complicated. So 2x cancel out. Y is 7y. Z is negative z, 35. Okay, anyway. We'll get these 3 equations. So basically that is 4, 5, 6. 4, 5, 6. That's the easy way when we can do the elimination. We can eliminate the z, right? But here I don't want to eliminate the z. I want to eliminate the y because later when we do the matrix operation, we always follow the coefficients. Okay, follow the coefficient. I want to eliminate the y variables for the 5 and 6. How can we eliminate the y variable in equation 5 and 6? Let's take a look. We let 6 times 2 subtract 5 times 7. Okay, so 6 times 2 gonna be 14y, 2z, 54. And equation 5 times 7 gonna be 14y, 7z, 49. Okay, so 6 times 2 gonna be 2, 14y times 2, negative 2z times 2, 34. 7 times 5, so gonna be 7, 14y, negative 7z, sorry, 7z. And times 7 gonna be 49. Okay, you see it? Okay, that's the subtraction. Now we do the subtraction. So negative 2z subtract this guy gonna be 5z. 14y subtract 14y gonna be 0. 54 subtract 49 gonna be what? Gonna be 5, right? You see it? And z equals what? Z equals 1. Aha, we solve it. We solve it. Very good. So we have now we can use back substitution. Back substitution. So back substitution, plugging back 2y minus 1 equals 7. We're gonna get y equals 4. And we're plugging back the first equation. Right? And we can get the solution set for this guy. It's 15, 4, and 1. You get it? So far, any questions? Back substitution, right? Now, I want to let you try another one. And that's gonna be the last example, okay? Okay, solve this equation system. Use the elimination. Okay, elimination. Basically, here is x1 just like x, x2 like y, x3 like z, right? Three variables, x, y, z. As you change it to x1, x2, x3, the same things. Okay.
Second line, instead of 3, x1.
We have 2x1. 2x1 subtract x2 minus 2x3 equals 2. Are you in this class?
Yeah, 231.
Math class?
Oh, no.
No.
My class then?
I think your class will be start with like 10 minutes later. Before that, there should be another class. It's mine.
Oh, okay. My bad. I'm sorry.
Did you guys get the answer? This question, this equation system is a little bit tricky. Who get the answer? No, you couldn't get the answer. Oh, that's so bad. How about you? More time? It's a little bit tricky, to be honest with you. I will never give you that easy question. Huh? No solution. Yeah, right. Okay. Good job. Shall be no solution. Okay, I'm gonna show you on board. Okay. So 1, 2, 3. Like we did before, we want to eliminate the x1, right? For the x1 in equation 2 and equation 3, what are we gonna do? We need to subtract 2 times x1 because here's 2x1. So we let the first equation times 2, then we do the subtraction, right? 2, we'll just write down 2x1 plus 2x3 equals 2. So we're gonna do the subtraction. We have cancel out negative x2, subtract negative 6x2, gonna be plus x2, 5x2, and negative 2x3, subtract, gonna be negative 4x3. 2 minus 2 equals 0. Okay, that's the first one. Second one, 3 minus 1. That's very straightforward, right? x1, subtract x1, cancel out. And now we're gonna get what? We have 5x2 okay, and then we can boil down to this equation system. Boils down to the equation system gonna be x1 Now we want to eliminate the x2 in the third equation. Right? What are we gonna do? Subtraction 6 minus 5. Sorry. 6 minus 5. What are we gonna get? 5x2 gonna be 0. Negative 4 x3 gonna be 0. Negative 2 equals negative 2, huh? So 0 equals negative 2. That's impossible. That means what? No solution, right? No solution. That's it. I already said it before. Well, an equation system, there will be exactly one solution. That could be infinity solution, and that could be no solution. Okay, for this case, we have no solution. Next class, I'm gonna show you guys that our equation can have infinity solution for 3x3 linear system. Okay, that's it. Any questions? No question. We're gonna wrap up class here. Thank you for coming.